Here we're going to look at the 2004 Advanced Higher Paper question 2. It asks us to obtain the binomial expansion of a squared minus 3 all to the power of 4. Now remember, binomial expansion, it's the sum of n terms from r equals 0 to n of n r bracket x to the power of n minus r y to the power of r. Now x and y come from the two parts of the bracket here where we have to identify them and we have to make sure we have them right. Now one key thing to note is that this is taken when we have x plus y to the power. So x plus y to the power of n. So in this case, my a squared minus 3, to get it in that format, I have to write it as a squared plus negative 3. So for the example I've got here, that's going to be my x, and that's going to be my y, the negative 3. So what I can then say is I can expand it doing that way, and I can say that a squared minus 3 to the power of 4 is equal to 40, then it's times x to the power of n minus r, so that's going to be x to the power of 4, plus 4, 1, x cubed y, then plus 4, 2, x squared y squared, plus 4, 3, x times y cubed, and then plus 4, 4, y to the power of 4. Now remember, in this format, each of the x's and y's, as I say, have to now be replaced by their parts from here, and each of these come from the binomial coefficient formula. But because it's the fourth row, I know that that's going to equal 1, that's going to equal 4, I'm going to get 6 from there, 4 from there, and 1 from there. I would suggest learning the first, 4, maybe 5 lines of the binomial expansion triangle before you have to sit and muck about with the formula every single time. It would just make your life a lot easier. So if I substitute all of these bits in, what I'm going to end up with is 1 times what would be x, so it would be the a squared to the power of 4, plus 4 times the a squared, this time cubed, times the y, which in this case is negative 3. I'm then going to have plus 6 times ax squared, so this time it's a squared squared, this time times the negative 3 squared. I'm then going to have plus 4 times the x, which in this case is just a squared, times the negative 3 cubed. I'm then going to have plus 1 times negative 3 to the power of 4. All I need to do now is simplify this whole expression down, and I've done it. I've expanded it using the binomial expansion. So a squared to the power of 4, that gives me a to the power of 8. I've then got 4 times negative 3, so that's going to give me negative 12. A squared to the power of 3 is going to give me a to the power of 6. I've then got 6 times negative 3 squared. Well, negative 3 squared is 9, so that's going to be plus 54. A squared squared, so plus 54a to the power of 4. I've then got 4 times negative 3 cubed. Well, negative 3 cubed is negative 27. 4 times negative 27. That'll then end up giving me negative 108 a squared. And then I've got my final term here, negative 3 to the power of 4. Well, it's an even power, so it's going to be plus. Then 3 to the power of 4, well, 3 cubed is 27. So 27 times 3 gives me 81. So it's going to be plus 81. So there you go, I've used the binomial expansion in order to expand those brackets out. If I didn't, I'd have to expand it out one bracket at a time, simplify each set of terms every single time, then do it again, simplify another set of terms, and continue on like that. It's a lot more work than remembering how to use the binomial expansion in order to do it, and it makes the life a heck of a lot easier than it could be.